All right, physics fans, here we go. Our third lesson on motion is interpreting graphs. I don't actually get you to draw many graphs in this course. I think, for different reasons it'll come up, but mostly I want you to be able to interpret them, okay? So the first graph is what we call a position time graph. And so the important things to know is the horizontal axis will be time, always. The vertical, the up-down, is going to be the position of an object with direction, and the slope works out to the velocity. So the steeper it is, the faster it's going, pretty much. So here's just a little example of one. Okay, so here I go. Here's the y-axis, and that's going to be position of Ferd. I don't know, someone. Let's say Ferd. And his position north of something. It could be north of the door or north of his house or something. We don't have any units on this one. And this axis is the time. So at the beginning of time, or his time, or the situation, Ferd is at the start point, whatever that is, right? And so what's going on here then, if you look at it, he starts moving at a steady pace, constant, because the slope is velocity. So because that slope is constant, it's not curved, he's got a constant velocity moving north. And then here, his position's not changing, right? So his position's not changing, so he's standing still. Okay? Here, he starts moving back to where he started, and then he continues to go, right? So he gets back to his start point, then he moves even south of where he started. And so he's moving south the whole time, and he's moving at a constant speed, right? Because the slope is constant, it's a straight line. So at that particular moment in time, he's crossing where he started. And then this last part is he's standing still south of the start position. Again, we don't have any numbers to go by here, but that's, you want to describe that, that's what it is. Okay? So sometimes you see position time graphs that are curved, and there you really can't do many calculations, but you can interpret it. So say we have on this time, we've got position east on this axis, and then time on the horizontal. So you can say, he's starting here, not going very fast, because it's not very steep, right? Like if you sort of tried to measure the slope at that point, it's pretty much zero. So he starts at a rest, and he speeds up, and here he's going the fastest because it's most steep here. So Ferd, or whatever object is in this graph, he's speeding up or accelerating in the east direction. This is what we call non-uniform motion. Uniform motion is stuff like this, where you have straight lines. Non-uniform motion, you've got curves. Okay, not a lot of calculations to do there, but you should be able to look at that and say, Ferd, or whoever's in this graph, whoever's this graph is tracking, is speeding up. This one too, this time Ferd's, whatever we call, I'm calling it the reference point now, wherever we're measuring him from. So if you choose, by the way, one kind of neat lab with this is you can use the motion sensors, and you can sort of say this is 100, which is a big number, but in that one you might be standing 3 meters, I think it is, from the wall, and you're holding the motion sensor. So your start point is 3 meters. And then if you walk towards the wall, it'd be kind of like this. Walking, like start at rest, speed up, hit the wall. Now in this case, Ferd's able to go right past the wall, but you can't. You can't go through the wall now unless it's a door and someone opens the door. But anyway, let's not get too philosophical with our position time graphs. The main thing is that he's starting here not very slow, basically at a rest. He's east of whatever we're calling this point, the wall, but it takes him about 12 seconds to get to the reference point, and maybe that's the wall, and maybe he walks right through the wall and he keeps speeding up. So he's speeding up, he ends up west of the starting point. Okay, so he's really moving west the whole time though. He starts east of the reference point, but he's moving west the whole time. So the object in this graph, or Ferd in this case, is accelerating in the west direction. because he starts at almost 0 and he speeds up. In this case, Ferd's moving east but slowing down. Let's see. So he's starting, the positive axis is east, and he's actually see how it's more steep here than here? In fact, here it looks like it's 0, right? So this means that Ferd, or whoever in this case, is starting out at a fast pace and then slows down over time. And so that's, moving east but slowing down. Here's an interesting thing. He is accelerating, but he's not accelerating in the east direction, because if he's accelerating in the east direction, he'd be speeding up. Instead, he's slowing down, so that's actually, and we'll talk about acceleration more in the next note, but really he's accelerating in the west direction, which is kind of a weird idea. But the main thing is that you understand the graph. Okay, just a quick thing on velocity time graphs. X-axis is always time, same as position time. The up-down axis this time is velocity instead of position. And the slope would be the acceleration, if we were going to calculate it. So, just looking at this situation. So say in this case, we've got, here's our velocity north is the positive, which means, by the way, that's velocity south down here. And let's just see what's going on here. So here, straight line, this means he's got some, Ferd in this case, has got some velocity constant, because it's not changing, in the north direction. So say 5 meters per second north, for example. Then what happens is he starts to slow down, because as he goes towards this point, that's not where he's headed necessarily. What it is this line here represents 0 velocity. So we're at this point, say he's 5 meters per second. Here he might be 2.5. Here he'll be 0. But now he starts to speed up, moving in the other direction. So it's almost like what's happening here then is constant pace, slows down, turns around. This means at this point he's changed direction. He turns around and is speeding up in the south direction. Now he's going at a constant speed in the south direction. And now he's slowing down, ending at a rest. Okay? So that you might look at that and think he's speeding up, but he's not speeding up because, again, say this was 10 meters per second south. Okay? Well, that means this is 5 meters per second south, and this is 0 meters per second south. So in a velocity time graph, sometimes it's hard you get them confused with position time, but again, you'll have a little bit of practice with these as well. And the most you need to do is pretty much just interpret them and understand what's happening. There's not a lot of numbers that I care about. It's more understanding the idea of them. Okay, that's it for this one.